Oppenheimer wasn't the only scientist who started a revolution. A rare strain of mold led to a miracle drug, but this breakthrough was tainted by a secret. The scientist who made that discovery, Alexander Fleming, failed in a very specific way. This failure sparked a chain reaction spanning across 16 years and multiple continents, desperately converging onto a single date, June 6, 1944. My name is Jack. I'm an Australian scientist, college professor, and in 2020 I was named the Australian University Teacher of the Year. On this channel I cover the business of science and how it can transform all of our lives. Today, let's talk through 3 types of failure that scientists experience all the time, but more importantly, the skills we use to bounce right back. Failure is inevitable in any job, but scientists experience it all within a condensed period of time. We're literally trying to discover something that no one has ever discovered before, so there's plenty of mistakes to go around. Today, I'm drawing inspiration from the scientists who overcame it all just in time to save millions of Allied troops on D-Day in World War II. But first, let's rewind to 1928. A rare strain of Penicillium notatum that secreted mold juice. This mold juice that Alexander Fleming discovered killed a wide range of harmful bacteria. The same bacteria that caused festering wound infections that killed so many soldiers over the course of drawn-out warfare. Surely this was the eureka moment, so how did Fleming fail? Fleming and his team could not purify the mold juice. The active ingredient, the penicillin antibiotic within the mold juice, was full of contaminants and super unstable. There was no way to extract enough penicillin to treat patients or run trials, so when Fleming published the finding, he downplayed its medical applications. This was a lost opportunity and leads us to failure 1, the founder's blind spot. The book, The Innovator's DNA, outlined skills of discovery needed for breakthroughs, including associative thinking, observing, and experimenting. It's a mix between creativity and hubris, having the audacity to do something no one else has tried before. Is there an association between mold and dead bacteria? Observing how consistently mold juice kills the bacteria, and designing follow-up experiments to see which bacteria this all affects. But to tap into the full potential of the idea, that requires a different skill set and more resources, way more resources, than Fleming could access at that point in time. Maybe Fleming had the vision, but the technology of the time couldn't catch up to it. Apple, Google, Microsoft, or have CEOs who are not the original founders but are able to deliver on that original vision because of the diverse capabilities they've accumulated over time. Is your team made up of complementary pieces? Have you strategically hired people with different perspectives that in turn offset any blind spot you may have as the original founder? Or have you just recruited mini clones of yourself with too much skill set redundancy? On the flip side, if you're looking for a new team to join, is fitting in the most useful criteria for building your career? Would you not have more value if you were the odd one out in some way? Being more strategic with the direction of our team building, valuing diversity of opinion and expertise, can ease the transition of your idea for a bigger audience when the time is right. Timing wasn't right for Fleming in 1928. Not only in the limitations of technology of the time, but also in their motivation. The idea that the British Empire would need thousands of liters of life-saving drugs wasn't so obvious in 1928, but it became the reality very shortly. Throughout the next decade, the slow drumbeat of war accelerated. Invasions, civil wars, border conflicts, until the Second World War broke out across Europe in 1939. Fleming's discovery paved the way for Florey and Chain, who of course saw the desperate need for vast quantities of penicillin as part of the wartime effort. Their work started in 1939 to try and fix the problem Fleming could not overcome. Florey and Chain benefited from the advances in technology, using a counter-current system and a newly invented type of chromatography to purify penicillin. Extracting enough of it to run clinical trials was a huge undertaking. 500 liters of mold juice every week in bars, bedpans, whatever they could spare, all to make a penicillin factory on a shoestring budget. Florey and Chain had pushed the boulder up the hill a little more than Fleming. Enough penicillin to do some testing on mice, treat some humans, but not completely. They had tried to optimize penicillin production as much as they could within the confines of the knowledge and facilities. And this is the classic case of the exploration-exploitation dilemma. In any decision-making process, we could emphasize exploration, trying new options to broaden the scope of our knowledge in a way that hopefully leads to better future outcomes, or exploitation. Only trying what has been done before, but doubling down to optimize it in every conceivable way, with the hope that streamlined efficiency will bring better outcomes than something brand new you've never tried before. It doesn't matter in the short term whether you explore or exploit at any given moment, but over the long term, you need to have a healthy dose of both strategies. Most college students are working part-time jobs to pay the rent, retail, restaurants, call centers, and exploring all the different jobs you can do in the marketplace while learning new skills from each of them. But if you don't start putting together a strategy for how you're choosing your next job, your long-term career arc is lost and it's hard for employers to take you seriously. This is too much exploration. Some scientists become a specialist in one laboratory technique that no one else in the world can do it better, unless they're consciously trying to apply their skills towards different problems, different contexts all the time. They can get stuck, pigeonholed by the over-exploitation of their own expertise. This explore-exploit trade-off is what led to failure to over-exploitation. Fleury and Chain leaned too much on the exploit side of the equation in trying to optimize their system for penicillin production. No matter how many extra fermentation vats they used, the strain of mold they were using was simply not fast enough at producing penicillin. What actually needed to happen was reverting back to exploration, back to the drawing board to see how else they could solve this problem, and that's exactly what they did. A worldwide search for mold took off. Soil samples were sent in all around the world, all in an effort to find a needle in the haystack, the mold that would produce penicillin exponentially faster than the one they were working with. They veered back towards explore to great effect, and once they found this miracle mold from a moldy cantaloupe in a nearby fruit market of all places, they veered back again, this time towards exploit, substituting different sugars in a growth media, zapping the mold with UV radiation and X-rays, all to optimize penicillin production that much more. After multiple explore-exploit cycles, they could now produce billions of units of penicillin, but now here's the kicker. They'd run out of money to do this at scale. They would need to overcome failure 3, competing interests, have a shot at supporting the Allies ahead of D-Day. In 1941, Fleury took his mold and shopped it around pharma companies in the US. 3 specific companies, Merck, Squibb, and Lilly, were already conducting their own penicillin research at that time. Why would they fund the work of the scientists from Oxford when they already had their own version of penicillin in the works? And of course, this was against the backdrop where the USA were in the middle of drawn-out negotiations with Japan and weren't yet fully committed to the war effort with the Allies. Everything changed on December 7th, 1941, after the Japanese military bombed Pearl Harbor. Declarations of war rang out across the world, and the geopolitical tensions in the US were at an all-time high. Were these US companies being nationalistic or capitalistic in their reluctance to assist Fleury right away? Fleury's scientific credibility actually works against him in this scenario. Nothing breeds paranoia like wartime. Fleury's communication skills, rather than his scientific bona fides, overcame these competing interests, broken multiple agreements between the US and the British Empire, the government, and different combinations of pharma companies. Using Fleury's technology in the facilities of 21 companies, thousands of liters of penicillin were produced each and every week, all to supply 24,000 Allied troops about to storm Normandy to ambush German infantry on D-Day in World War II. Fleming, Fleury, and Chain were awarded the Nobel Prize in Medicine of 1945, the pinnacle of success in science, but they had to overcome systematic failure every step of the way. This is the beauty and the cruelty of science on display all at once. Isn't it interesting that the breakthrough in technology wasn't enough on its own? That at the end of the day, it came down to communication skills that fostered human connection between these competing companies in order to save the day. If you're interested in how I use this YouTube channel to build a transferable set of communication skills as a scientist, you can find that video linked here when it's ready to go. I'm Jack, hope to connect with you again next time around.